Welcome back, Pre-Calc. Hope you all are well. Our objective today is going to be to solve initial value problems. So we're going to be looking at some more exponential and log equations. What we're going to be doing is actually looking at the algebra part of differential equations. So we have done the calculus part for you, and which is really typically just 2 steps for the types of differential equations we look at in Calc 1 and Calc 2. And then the rest of that problem is all algebra. So we're going to focus on the algebra now so that we can really pay attention and focus on the calculus next year. I've got the checklist on the screen. You know what to do from here. For applause on your screen, go ahead and copy example 1 for me. Okay, we're back. So what we have done is these steps in calculus are called separate and integrate, and we've done those 2 steps for you already, and this is where you might land after those 2 steps. What our next goals are, first to find this constant c. And the way we use that, the way we do that, is to look at this, which is called your initial condition or your initial value. This is just an ordered pair, so let's write this as 0, 20. And typically we would use x and y. You can see that in this case we're using b instead of y. This problem came from a problem where they're talking about the baby bird's weight, so they're using b for the baby bird. Okay, so first goal is to find c by plugging in 0 for x and 20 for b. And once we've got c, we're going to plug it back into this equation, and then our ultimate goal is going to be to solve for your dependent variable, which in this case is capital B. All right, so let's start by plugging 0 in for x and 20 for b. So I've got ln of the absolute value of 100 minus 20 equals 0 over 5 plus c. So let's clean it up a little bit. 100 minus 20 is 80. Absolute value of 80 is just 80. So I'm going to say ln of 80 equals c. Okay, so now what we're going to do is come back to where we started, which was here, and I'm going to plug in ln of 80 for c. So I've got ln of the absolute value of 100 minus b equals x over 5, and then for c I'm going to plug in ln of 80. All right, now you've got logs in some terms and not in others, so do we remember strategy here? Our strategy is going to be to get the logs on one side, everything else on the other, and I recommend getting the logs on the side that would make this log positive, because ultimately we want to solve for b. So this log's already positive, so I'm going to get the logs on the left. So I'll have minus ln of 80. And then on the right, I just have that x over 5. Now the point of getting your logs on one side is to do what? Is to condense. So I've got 2 logs separated by subtraction, so I can make these 1 log using what operation on the inside? Division. So in the numerator I have absolute value of 100 minus b. In the denominator I have 80. On the right side I still have x over 5. Okay, now the next thing we want to get rid of, remember we're solving for b, so the next thing we want to get rid of is ln. So let's take e of both sides. So when I exponentiate the left, the ln goes away, and I'm left with absolute value of 100 minus b all over 80. But what I do to one side, I have to do to the other. So the other side is e to the x over 5. Again, trying to get b by itself, so let's multiply both sides by 80. Now I need to get rid of the absolute value, so I can drop the absolute value on the left if I add what on the right? If I add a plus or minus, okay, and this is true anytime you want to drop an absolute value. You don't, even if you have absolute value on both sides, you can't just drop them on both sides. You only get to drop them on one side if you add a plus or minus on the other side. Okay, and then we are going to subtract 100, so I get negative b equals negative 100 plus or minus 80e to the x over 5, and then finally we'll just divide everything by negative 1. So b equals 100. Dividing this by negative 1 is still plus or minus 80e to the x over 5. Okay, so we've got b by itself. Now there's one more thing we need to be mindful of. You are trying to solve for a function, so b of x in this case. Right now I don't have a function because I have a plus or minus, meaning I've got two outputs for most inputs. So I've got to choose plus or minus, and you don't get to just pick your favorite. There's one wrong, one correct. So the way we do that is come back to our initial value, this point 0, 20. Plug it back in for me. So let's do that. We've got 20 equals 100 plus or minus 80e to the 0 over 5, right? Okay, now what we're going to do is pick the sign, the positive or the negative, that gives us a true statement. So let's clean up the right side a bit. So e to the 0 over 5 is e to the 0. Anything to the 0 is what? Is 1. So 80 times 1 is 80. So we've got 100 plus or minus 80. So what symbol, the positive or the negative, gives us a true statement here? The negative, we want 20 equals 100 minus 80. So my final answer is b equals 100 minus 80 e to the x over 5. We did it. Force pause on your screen. Go ahead and copy example 2 for me. All right, so we've got this initial condition of y of 1 equals 2. Again, I do recommend writing this as an ordered pair so it's really so that you don't accidentally mix up x and y, okay? So what's our first order of business? First thing we want to do is figure out what is c. We're going to do that by plugging in 1 for x and 2 for y. So I've got negative 1 over 2 times 2 squared equals 1 squared over 2 plus c. All right, so in the denominator here, I have 2 times 4, so I have 8 in the denominator. And then just 1 over 2 plus c on the right side. So 1 over 2 at the denominator of 8 is 4 over 8. So negative 1 over 8 minus 4 over 8 is going to be negative 5 over 8. So that's my c value. Okay, now we are going to come back to the original equation that you got here. And what we're going to do is plug in negative 5 over 8 for c. And then what is our ultimate goal? Our ultimate goal is to get y by itself. So I've got negative 1 over 2y squared equals x squared over 2, and then minus 5/8. Okay, so let's start working here. What do we think about just changing all the signs, first of all, to get rid of this negative? Are we okay with that? Let's go positive, negative, positive. All right, now I've got this y squared in the denominator. Whenever you have a variable in the denominator and you're trying to solve for it, I recommend rewriting this with a negative exponent. Okay, so we're going to do that in a bit. Let's first get rid of this 1/2 by multiplying everything by what? By 2. So when I multiply the left side by 2, the 1/2 is gone, but I still have the 1 over y squared. Okay, don't lose that placeholder. Make sure that y squared doesn't magically float to the top. All right, when I multiply this term by 2, I have just negative x squared. And when I multiply this term by 2, I have 5/4, or 10 over 8. Okay, so now, again, when you've got your unknown in the denominator, go ahead and rewrite that term. So instead of 1 over y squared, I can rewrite this as y to the what? To the negative 2. So let's do that. So I've got y to the negative 2. Okay, and then when we want to get rid of an exponent like this, what I can do is take the reciprocal of that power. So that power right now is negative 2. If I flip it, it would be negative 1 over 2. What I do to one side, I have to do to the other. And don't drop your plus or minus whenever you have an even power in the denominator of your exponent, because remember, that's like taking the square root, right? And whenever I square root, I need a plus or minus. Okay, so now look at your power. When I take a power, raise it to another power, what do? I multiply. -2 times -1/2 is 1, which was the whole point of that. So now I just have y by itself, plus or minus, and I'm going to leave all of this to the -1/2 power. Okay, now I can't keep it as a plus or minus. I need to come back to my initial condition. So if I plug in 1 for x, 2 for y, I get 2 equals plus or minus -1 squared plus 5/4, all to the -1/2. Well, the inside becomes just 1/4. A negative exponent means to do what? Means to flip it. So this is the same as 4 to the positive 1/2. And the 4 to the positive 1/2 is what? Is 2. You're taking the square root of 4. So which sign, the positive or the negative, makes this a true statement? The positive. So my final answer is y equals plus or minus -x squared plus 5/4, all to the -1/2. Sorry, not plus or minus there. We want just the positive branch, right? So you can leave it off or put a plus there. All right, last example, go ahead and copy it in your notes. Okay, so our first order of business is what? Is to find C. So let's write this as 1, 0 or 0, 1. 1, 0, so I'm going to plug in 1 for x, 0 for y. All right, so we've got -0 minus 1 to the -1 equals 1 over pi sine of pi times 1, so pi plus c. All right, let's be careful here. So here in parentheses I have a -1. -1 power means what? Means take the reciprocal. So that the reciprocal of -1 is -1, but then I have times this understood -1, so I get +1 here. Okay, what is sine of pi? Sine of pi is 0. 0 times anything is 0, so I'm getting that c is 1. Okay, so let's come back to the original, rewrite it, and plug in what we got for c. So I've got -y minus 1 to the -1 equals 1 over pi sine of pi x plus 1. All right, we're trying to solve for y, so what would you want to get rid of first? Let's get rid of that negative. We can just change all the signs again. So we've got the quantity y minus 1 to the -1 equals -1 over pi sine of pi x minus 1. All right, now we need to get rid of this -1. So take the reciprocal of that power and raise both sides to that new power. So it's the reciprocal of -1. It's -1. You're saying what times -1 is 1, right? And what I do to one side, I have to do to the other. So these cancel, and I'm left with just y minus 1 on the left. Then I have all of this on the right. All of that to the -1, and then all I need to do is add 1 to get y by itself. And you can put the +1 first or after this expression. So I'm going to go ahead and do this piece. +1. Okay, notice this time we did not have to pick which branch, positive or negative. That won't happen every time. Nonetheless, it's always a good idea to plug these values in. So I can, and just double check my work, so I can tell when I put 1 in for x, I get sine of pi here, which is 0. So I get -1 in parentheses, and then I need to take the reciprocal, so that's still -1. So all of this is -1 plus 1 is 0. So this does indeed check. All right, you all. The assignment is going to be 10 problems, so just make sure you show all your work because that'll be part of your notebook check. The assignment is placed as a PDF, and the key is there for you to check as you go as well. All right, I will see you next time.